Welcome to the world of fungi. Hope you guys are doing well today. And in this presentation, I'm just going to go over some important features and information on fungus, specifically their structure and function, and the impact on life. So let's get started. First off, there's some really important vocab words that I would like you guys to know for not only the quiz on fungus, but when you get to the final as well. So when we talk about structure, we're always talking about the cellular structure as well as more of the gross anatomy, if you will, so at the larger scale of the fungi. So let's actually start with the large and go smaller. So mycelium, and if we use our prefixes here, MYC in parentheses O, myco, means fungus. So mycelium is in a fungus, and mycelium is an entire mass, if you will, and that could be one way you can remember it, mass of M and M, a mass of hyphae, okay? And mycelium are always found underneath the ground, okay? And for academic students, you're going to find this vocab word in section 21.4, and that's on page 619. And in honors, that's actually on page 404. So figure 22.1 talks a little bit about mycelium. So I would take some time to read that and make sure you're familiar with that. So mycelium, again, is a mass of hyphae found underneath the ground. Where hyphae, up here, hyphae is just one entire strand. So if I were going to use something in the classroom, I could pick pipe cleaners, and so one individual pipe cleaner would be like a hyphae, and if I had a bunch of pipe cleaners and just kind of put them all together, that would be mycelium. So a hyphae, again, is just one tiny piece here, like a strand or a thread, and mycelium is a mass. Within each hyphae, you can actually find nuclei, could have one or more nuclei per cell, and sometimes hyphae can be separated by these cross walls. And these cross walls actually have another term that's not highlighted here, but they're called septum. And septum, again, if we use our prefixes, septa means division or separation between components. So in the honors textbook, it actually shows on page 404 the hyphae with cross sections, and there's some septa there. In the academic book on page 619, it doesn't show septa, but it does show cross walls, and those cross walls are called septa. So that's our fungi structure. Again, those cell walls are made of chitin, and that's actually highlighted in your textbook. In the honors textbook, it would be on page 404, and again in academic 619. So they can be multicellular. They also can be unicellular. The example of a unicellular fungus would be yeast. The cross walls are called septa, and mycelium, which we find underneath the ground, is the feeding structure of the fungus. So with all the organisms that we go over, whether it be bacteria, protists, fungi, plants, or animals, we're always going to talk about their nutrition. So fungus is, as a group of organisms, they're heterotrophic. They absorb their food, and they do that by secreting enzymes to the surrounding food source, breaking it down into kind of edible, if you will, components. So once that particular structure has been enzymatically broken down, the organism can absorb that. It's much smaller so that it can actually be absorbed. So what the things that they eat would be things like logs, dead organisms, wastes of living organisms, so they're really good at recycling things. They also can be parasitic. And so the next slide actually shows this particular structure would be the fungus right here. Okay, and it actually secretes its enzymes out into the surrounding environment. So this black piece right here would be something that would be interested in eating. So whether it be this fungus or this fungus, they're going to be secreting those enzymes out into this particular item that they're interested in eating. So once they secrete those enzymes, it breaks it down. So you can see that this was larger. It breaks it down into these smaller pieces. And once those are small enough, you see how it says here it's a soluble product, those particular pieces now can be easily absorbed into the fungus. So again, secreting the enzyme, breaking this down into the smaller particles, and those particles can then be absorbed. They're small enough to actually get in, and then the fungus can take those particular food items and send it off to the next cell within that multicellular structure. So that's actually how fungus absorb their nutrition. How they reproduce: probably 8% of them reproduce asexually by producing spores, and the spores are what we call hardy. They can withstand a lot of harsh conditions. If conditions are not good, they can reproduce sexually, and they also have some fungus that are able to reproduce sexually as well. And I want you to think about what are some benefits of producing spores, how many of them are made, and what are some of the benefits of that. And if you could take a moment to think that over and put that in your notes, that would be great. For honors students, I'd like you to look at page 405 where it says fungi propagate by spores. Look a little bit about that, read that section, and jot down some notes that you think of the benefits of those spores would be. And that goes from 405 to 406. And then come on back. One of the most important things that fungus do, as well as some other organisms, but this is an important concept for us to understand as we go forward in the rest of the year, is that there's different symbiotic relationships. These page numbers are actually coordinate with the honors textbook. So the symbiotic relationship types are parasites, with one benefits and the other one is harmed; mutualism, where both of them are benefit; and commensalism, where one organism benefits where the other is neither helped nor harmed. So keeping those in mind as we go on to the symbiotic relationships that fungus can have. One of the most important symbiotic relationships, what this would be mutualistic, is between fungus and algae, or fungus and a cyanobacteria. So fungus and algae or cyanobacteria form these symbiotic relationships, and these are pictures of those symbiotic relationships where the fungi provides a place for the other organism to live, and it provides them with a necessary what's the word I want to use? Substrate for photosynthesis. Now, one of the substrates in photosynthesis is water. So the fungus provides water to the algae or cyanobacteria, and then the algae or cyanobacteria uses that water to undergo photosynthesis. So once the algae does, or cyanobacteria does photosynthesis, the product of that is glucose. So then the fungus benefits because through photosynthesis the algae or cyanobacteria makes glucose, and then the fungus is fed. So they're in this kind of love fest, if you will, where they're both benefiting. So in the honors textbook, the lichen is actually on page 412, and it actually shows a figure of that on 2213, and it also tells you a little bit about the importance of that. So I would read that section. There's only a couple paragraphs there, and that will really be an important thing to feel comfortable on. The academics is on page 623, and that also correlates with the worksheet that we did in class. So you might want to just review those pictures as well as what's on 623 if you're academic. Another relationship that we have between fungus and another organism is between the plant roots and fungi, and that's called a mycorrhizae. Mycorrhizae is on page 413 for honors, and this would be on page 624 if you're academic. The fungus here again is providing the plant with water and minerals, and then because the plant in the roots is storing sugar in that particular part, the plant will provide fungus with a nutrient, specifically glucose. Now, fungus also has some good and bads. The bad is that it can cause diseases in both plants and animals, and this picture shows us what the devastation of a fungal disease in plants had. These elms, this was in California, these elm trees were got this particular fungal disease, and it basically caused them to die, and now this is what it looks like here. So it's the same neighborhood, just without the trees because of that particular disease. So that's what it can do to plants. And in humans, we can actually get fungal diseases. Athlete's foot is one fungal disease. Ringworm is another. Vaginal yeast infections or candida is another infection that humans can get. So that's some of the negatives of that. Some of the positives is that it actually, we can make food, blue cheese, here's some truffles, yeast makes bread, and if you've ever had delicious mushrooms on pizza or some other things, they have a lot of good uses for us from a culinary standpoint. Penicillin is made from a fungus, and so a lot of medications can be made by the use of fungus. So those are some of the goods as well. A last positive, and this actually could be positive and a negative, is that they're important recyclers of organic matter. The bad thing here is that they don't know the difference between your house wood and something that's just a dead tree. So it's going to take care of or decompose things that are good, dead organisms or logs that are, you want to go away, but it also can decompose things that are negative, like your house. So, and in that process, it's going to recycle carbon, it's going to recycle nitrogen back into the environment, which is a very positive thing. So for honor students, what I think that I'd like you guys to do here is look at page 414 and 415, because it actually talks a little bit about how fungus can be important decomposers and how they affect humans. And this would also be a great compare and contrast question about the positives and negatives of fungi. How some examples of human diseases would be an important thing to jot down, what toxins they can actually make, some of the pluses that they can do, what medications are made from them, and some important culinary things that we can actually get from fungus. So that's what I'd like you guys to read and jot down in your notes. So you want to take a couple minutes to go through page 414, 415, and 416 and jot some of those positives and negatives to fungi. So I hope that that's been helpful, and I hope you guys have a great afternoon, morning, or evening, depending on when you're watching this. See you soon.